I'm Anil Kumar. Welcome to my series on trigonometry. We'll discuss maximum and minimum values. So let's begin with sine theta itself. These are a few examples which we are going to actually discuss in this particular video. Let's start with sine theta, which is the parent function for all trigonometric functions we are going to discuss here. You will notice I only have sine and cosine. So we'll take up cotangent, tangent and other functions in the second video. Now when we say sine theta, it could have minimum value of -1 and maximum value of +1. So that is the range for sine theta. If you have square of this, or if you have cos square theta, you'll always get positive or non-negative values. You could get 0 as the minimum value and 1 remains as the maximum value. Now, whether it is theta, 2 theta, 5 theta or 10 theta, it doesn't really matter. This is a horizontal transformation which will compress the wave, but as far as the range is concerned, it's going to remain between -1 and +1. Correct? So that is kind of important to understand. Now, if I translate this function 5 units up, basically I'm adding 5 on both the sides. So if I add 5 on the maximum side, it becomes 5 plus 1 as 6. And when I add to the minimum side, 5 minus 1 is 4, right? So we get our sine wave between 4 and 6. When we have 2 minus sine theta, then of course the minimum value will be the value which is maximum for sine theta taken away from 2, right? So what is that value? So that is +1. So if I remove +1 here, I get 2, taking away the value, I get 1, right? Now if I add -1, then what do I get? So that becomes 3. You get the idea. So this becomes a value between 3 and 1. Well, inequality of this type could be solved. Let me take a step here to solve this. We have all this, right? If I have minus sine, let me do it here, right? So if I have minus sine theta, in that case, it becomes kind of like this, right? All this inequality signs changes and everything becomes negative of what it was. Now here I have +2, right? So if I write here 2 minus sine theta, correct? That is to say I'm adding 2 to these limits. So it becomes 3 here. And when I add 2, I get 2 minus 1 as 1. You understand? You could write like this also. Basically, we're trying to say that 2 minus sine theta will be between 1 and 3. Both included, right? Now when we have 5 minus cos square theta, if I put cos square theta is always going to be 0 or it is non-negative, right? Minimum is 0 and maximum is 1. To get the maximum value, I should take away the minimum, that is 0. 5 minus 0 is 5, and so that could be the maximum value. However, if I take away 1 from here, I get my minimum value of 4, correct? Then we come to these kinds of functions, which is a sine square theta plus b cos square theta. If we assume in this particular function that a is greater than b, right? If we assume that a is greater than b, then for this particular function, the value will be from a to b, right? Okay, but we'll keep it now. Okay, all these 4 we'll actually take up examples and then get back to them. That is better. Let's try to understand how to find their maximum and minimum values, and then we'll work out the examples. Perfect. So let's begin with the very first example, which is find the maximum and minimum value for 1 minus sine x cos x, right? So we'll now find the value for 1 minus sine x cos x. Now you may have to recall some of the trigonometric functions which you learned. One of them is sine 2 theta. Now sine 2 theta is sine 2 times sine theta cos theta. Now here we have sine x cos x. To make it 2 times, what we could do? We could do 2 over 2, right? Sine x cos x. That means it could be half times 2 sine x cos x, or 1 minus half times sine 2x. Perfect. Now we can actually get the maximum and minimum values. Clear, right? So how could we get? Well, let's do with inequalities fundamentals. So as far as the sine 2x value is concerned, it will be between -1 and +1, correct? If I multiply by half, then it becomes minus half sine 2x. If I multiply by negative, then this becomes half, sign changes, negative half sine 2x, right? Negative half. Clear? Now if I add 1, I get 1 plus half minus half sine 2x. We are adding 1, right? So what is this? This is 3 over 2. So that is the maximum value which this function can have. 1 minus half sine 2x. And 1 minus half is half. So we now get the maximum value as equal to 3 by 2 and minimum value as equal to half. Right? So that is how we could get the answer for the given function. Let's move on and take the next example, which is find the maximum and minimum value for 1 minus sine square x cos square x. Well, it is slightly different from what we had earlier. So if you compare, we were talking about sine x cos x. Now the power is 2, right? Well, it is interesting to remember this could be anything. It could be n also, right? So how do we solve such an equation for maximum minimum value? Let's see that part now. So it is 1 minus sine to the power of 2x cos square x, right? So we could write this as sine x cos x whole square. Now we'll again go with the same strategy of multiplying and dividing by 2, right? So we could write this as 2 over 2 sine x cos x whole square. So that is 1 minus half, right? And that becomes sine 2x whole square. Or it becomes 1 minus, it becomes 1 over 2 to the power of 2, right? Sine 2x. I could write this as like this. Okay. Now if you look into this again, we now have a square term here, right? We have a square term. So think about it like this. This could have maximum of 1 and minimum of. So in this case, we could have maximum value for sine square x as equal to 1 and minimum as equal to 0, right? So if this is 0, then I get value of the whole thing as 1 minus 0, which is 1, right? But if it is 1, I get 1 as 1 minus 1 over 4, right? Which gives you 4 minus 1 as 3 over 4, correct? So the value changes from 1 to 3 over 4, correct? But let me also show you the method which we did earlier once again. So here we'll again work with the inside function, which is sine square 2x, and this value sine square 2x cannot be negative, right? So it is going to be like this. Now if I multiply by 1 over 4, then I get 1 over 4 of sine square 2x, and here also I get 1 over 4, right? Now if I do negative of this, the sign changes, right? So we get negative 1 over 4 sine square 2x, negative 1 over 4. Adding 1, we get 1. 1 minus 1 over 4 sine square 2x greater than or equal to 1 minus 1 over 4. Or we get the limit between 1 and, let me complete this. So 4 minus 1 is 3 over 4, correct? So clearly you get the same answer, right? So it could be minimum of, this is the minimum value, right? Taking away maximum gives you minimum. Taking away minimum gives you maximum. Perfect? Does it make sense to you? Right. So that is what you get as your result, right? So it is interesting to note that if I have to the power of n, inside term will be 1 over 2 to the power of n, right? So if I have something like 1 minus sine to the power of nx, cos to the power of nx, in that case, this will be equal to 1 minus 1 over 2 to the power of n sine nx square, right? It will be kind of like this, or sorry, n power will be sine 2x to the power of n. Okay, I hope you get it, right? So this is sine 2x, okay? And like this, and this 2 changes to n. That's what I'm trying to figure out. Is it okay? So that is how it works out. So if you're only working on this part of the equation, in that case the minimum value can be 0 and the maximum will be 1 over 2 to the power of n, right? So that is how you could find for that particular function. Now let's see what is there in question number 3. Question number 3 is cos square x plus sine to the power of 4x. How do we solve this? Okay, let's try to get them in one kind of terms. That will be simpler for us to work, right? So cos square x, I could write this as 1 minus sine square x. And we have here sine to the power of 4x, right? Now, in these two terms, I can take sine square x common. So here I get 1 minus cos square x. Now that gives me sine square x, right? So it gives me sine square x times sine square x. So which is 1 minus sine to the power of 4x. Correct? Now, that really means that, let's go with our strategy. I hope you understand how we are doing our strategy. Now, if you're working on a multiple choice questions, you may have to work with different kinds of strategies, right? Here, we're systematically getting through the solutions. We'll talk about tricks later, okay? So, when this is a power is positive, it is always between 0 to 1. If I make it negative, right, let's try to understand this, what is happening here, right? Negative, right? It becomes 0. Now when you add 1, it becomes like this, 1 minus sine to the power of 4x, and you're adding 1, right? So it is between 1 and 0, right? Does it make sense to you, right? So that is how you actually get domain, rather range for such a function, right? So in this case, we again came with the conclusion that maximum value is 1 and the minimum value is 0 for the given function, right? Now that is going to be the case for most of the functions like this, sine square x and like this, right? So when you have such powers, even powers we are talking about, in that case, that is going to be a result. Okay, now here we have sine to the power of 4x plus cos to the power of 4x. Now both are to the power of 4. How are you going to solve this particular equation? You can actually pause the video now, answer, and then look into my suggestions. Now to answer such question, we should actually try to find a term with a perfect square, right? So the idea here is, we are given sine to the power of 4x plus cos to the power of 4x. We can add and subtract. Think like this. Think that this is sine square x whole square, right? Plus we already have cos square x whole square. But what is missing here is 2 times sine square x cos square x. This term is missing. So let's add and subtract this term, right? So we are kind of making it a perfect square. So the first 3 terms can be combined and written as sine square x plus cos square x whole square, right? So that is first three terms, and then we have minus 2 times sine square x cos square x, right? So this part we did earlier, and this part is just 1. Do you see that? So we could write this as 1 minus. Now we have 2 times sine square x cos square x. Okay, now what can we do? We need 4 times, right? So let's just keep 2 separate, right? Now we have sine square x cos square x, kind of like this. If I multiply and divide by 4, I get 2 times. Do you see the whole idea here? Okay, so we'll keep it like this, right? So basically what I'm trying to say here is that the numerator of this could be written as 2 times sine x cos x whole square. And this 1 over 4 I'm taking out, say. Does make sense to you? So what we did was that we took away this 4. 4 over 4 was 1, so I could always do that. Now, since I wanted square, I need 2 inside, so that's why I multiplied by 4. It makes sense, correct? So now we'll write this as 1 minus half, and this is sine 2x, right? So this is sine 2x, and the power is 2. Perfect. So we again get the form which we got earlier. Very familiar with that now, right? So you could now do that sine 2x, right? So I'm taking this time to show you once again so that you get conversant with this method, right? And then we could do minus 2 times we'll multiply. So we could do minus half times we are multiplying. So we are changing the signs. Do you see that? So it becomes minus half. And now we are going to add 1, right? So if you do like this, you will never, do a miscalculation. That's the whole idea. 1 minus half. We just added 1, right? So this value of the function is between 1, which is your maximum value, and half. Correct? So again, we got this answer, which is maximum value is equals to 1 and the minimum value is equal to half. Is that clear? So this is a very important strategy which many times you may have to apply, right? So I hope you got this particular step. We had a trinomial here which could be written as a perfect square, right? Okay, so the last question here is find maximum minimum value of sine cube x times cos cube x. Well, earlier we did square x, right? So this is like just expanding on that concept. So now we have sine cube x times cos cube x, which you will write this as sine x cos x to the power of 3, right? Now we know we need actually 2 sine x cos x. To get 2, I have to multiply and divide by both 2, right? So that means we have 1 over 2, right? And we have 2 sine x cos x, which could be written as sine 2x, and everything is cubed, right? So what you get here is 1 over 2 cubed. Do you see that? So last time we got 1 over 2 squared. So the power, if it is 3, 4, 5, this is the same power here on 2. And we get sine of cube of sine 2x. You get an idea. Now this is cube. Now for sine cube x, what is the range? It could be 2x, 3x or whatever. Cube x, negative 1 cube is negative 1. So it is between negative 1 and 1. Now when you multiply this by 1 over 2 cube, you get this limit between plus minus negative 2 cube on this side and 2 cube, 1 over 2 cube on the other side. That is to say, so that is the general formula, right? So basically you get within 2 to the power of n. Now it all depends on this power. If it is odd, then you get plus and minus. But if it is even, you get 0 and positive value. Is that clear to you, right? So clearly, we have a maximum value here, which is 1 over 8. and the minimum value is minus 1 over 8, which is 2 to the power of 3. So I hope with this you understand how we can solve such questions, right? Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.